So what was case number 1? What kind of gravitational force did we investigate? Too big or too small? Great. Okay, so now we go to the what? To the complete double other extreme. Okay. So today we actually what? We want to calculate the what? The magnitude. By the way, why am I never going to ask you about the direction of the gravitational force between any two objects? Because it's always going to be what? Inward, which is actually which is actually what? One of the questions in your quiz. Yes. Okay. What one student asked me. So one student asked me, like, I can't find it in the notes. I'm like, it's in the notes, and I pointed to that slide that says it's the attractive force, and he's like, yeah, but it doesn't say if it's in or out. And that's why I emphasize a lot that sometimes you could be a physics genius, but just because you don't know the meaning of a word, you still get what? Yes. So please, whenever you don't know, ask. Okay? All right. So calculate the magnitude of gravitational force between what? And, okay, what's the equation again? Fg equals what? Come on. Fg equals G, which is what? G is a what? G is a constant. So you're going to give it that. Then what? M1 times M2 times. The distance has to be, but from where to where? Now it's going to matter. Okay, everyone. So let's look at the second slide. Okay. So everyone, here is the Earth and the Moon. Okay. So what do I need to give you first? By the way, all the numbers are there on the slide, right there. So first of all, I need to give you the mass of the Earth, for example. So the mass of the Earth, sorry, apparently that's the what of the Earth. What's it? What is that? Is that diameter or radius? That's radius because it goes from here to the rim. Again, we're assuming that the Earth and the Moon are perfect what? Perfect spheres, not circles. Circle is 2D. Sphere or ball is 3D. Are they perfect sphere? No, they're not. But for an amazing approximation, we could definitely believe they are. Okay, so what's the radius of the Earth? 6,400 kilometers or 6,400 kilometers. Okay, how about it for the Moon? For the Moon, it's 1,735. So roughly 1/4. Everyone go ahead. Divide 6,400 by 1,735. You should get slightly over 25%. Sorry, slightly over 4, I mean. Yeah. Yeah, divide 6,400 by 1. How'd you get? You got 3.68. Yes. So the radius of the Moon is slightly less than what? 25% of the radius of the Earth. Okay. Now, the what? The mass. Sorry, what is that? What distance is that? The way it shows on the screen. From surface to surface. Are we just going to use that? Because if we do, the entire calculation is what? Is misdone. Okay, what do I need to give you still? Okay, sorry. You need to actually do this today. You have to figure a way to what? Find the total distance. Obviously, how are we going to do that? Pile up the entire thing. Yes. Okay, I need to give you the what? The mass of the Earth. Everyone, the mass of the Earth, as I mentioned a few times before, 5.98 times 10 to the 24 in kilograms. The mass of the Moon is 7.35 times 10 to the 22. So roughly, the Earth is about 90 times, 90, not exactly 100, 90 times as massive, not as big. Big means what? Big and small refer to what? Size or volume. Heavy and light refer to what? Mass. The actual mass or the actual heaviness of the what? Of the object. Okay, go ahead. You have all the numbers now. Go for it. You can do it in partners. Obviously, all of you should get the same answer because all of you are using the exact same numbers. Go. Come on, people. This is nothing but a math exercise to show me if you really know how to what? Plug in numbers, especially using your what? Your own machine. Yes. Oh, okay. Okay. Can someone remind me what's the equation again? F G. Okay. What's the value of G? 6.67. Go for it. Okay, everyone. Let me show you how to do it. Okay, pencils down. If you got anything incorrect, leave it. Leave it. Because I'm going to show you exactly how to quickly change it to be the correct right answer all over. All right. First of all, what's the equation? FG. And I'm going to actually show you how I'm going to do the whole thing in my head without using calculator even once. David Beckham, right? I bend it every time. All right. What's G? Okay. 6.67 times 10 to the negative 11 time. What goes on here? Yeah, it doesn't matter which, as long as you put the two masses, doesn't matter which one goes first. Times what? 10 to the, oh, sorry, was it? 7, yeah. 735 times 10 to the 22. All right. Distance. All right. Hold on. How do you get the distance anyway? What do? You have to add them all up. Okay. What am I giving you the distances in what unit? Anyone who got, how many people got 10 to the 26? That means you did not change it to meter. Anyone who got 10 to the 20, I told you, every mistake leads to a specific answer. I can just look and tell. Anyone who got 10 to the 26, that means what? You kept it in kilometers and you did not switch it to what? Which means your answer is correct, but your only power of 10 is what? Wrong or off. Okay. So, okay. So, okay. Oh, that means you also probably screwed up what? The powers of 10 for the masses. Hold on. We'll see. Okay. What's the first distance? 6,400 in what? By the way, you have to convert. Can you convert at the beginning? Can you convert at the end? I like to convert this one at the end. Why? I'd rather not do 3 conversions and add. I'd rather add once and convert once. So what's my first number? 6,400. What's my second number? I'm going to take the 1735. And what's the in-between distance? Please, 3, 8, 4, 0, 0, 0. Oh. This is it in what? In kilometers. Okay, all right. I have to make it in what? How do you go from kilometers to meters? You multiply by what? By 1,000. Each one of those has 1,000 breakdowns of a meter in it. So you multiply it by 1,000. Okay. Do you think this is a smart number to plug in the way it looks like this? No. We should use it in what? Scientific notation. What would this one be to scientific notation? 3 point times 10 to the power of, how many hops are you going to do from the invisible decimal point at the end? Nope. 8. Yes. Again, we have this button, which really makes our life simple. How many numbers should we keep? Sorry, how many digits should we keep? Oh, yeah, we can keep 3. Okay, let's keep 3. So that would be what? 3.92 times 10 to the 8. Okay, you see now how many mistakes we have done? Okay, what do you still need to do with this number according to what the equation wants you to do? Anyone who did not square it, anyone who did not square it means what? Your power of 10 will be bigger than what? Will be bigger than needed, because when you square a number at the bottom, it gets what? When you square a number in general, when you square this guy, it becomes what? Bigger. But you're gonna have to divide by it. What happens to the whole number when you divide by a big number? It gets what? So if you forgot to square it, it will be bigger than needed. You see, I can just look and I kind of guess where you took a wrong turn. All right, so it's gonna be what? 3.92 times 10 to the what? 8, all what? All squared. Okay, what can I do here? By the way, everyone, look at each one of those. Everyone, look at each one of those values. Each one of those values is written in scientific what? Which means each one of those has a what? Has a number part and a power of what? And a power of 10 part. Is that making sense? Why not have it simple and isolate what each part? So what does that mean? I'm going to isolate all of them. I'm going to isolate this one with this one with this one and with what? But it has to be what? Yes. Remember about what's the rule for a square of a multiple? This one just attacks one of them or both. Again, what's the rule? A, again, those in grade 11 functions. A times B to the n. What's the rule? A to the n times B to the n. How about this rule? A over B to the n. Same thing. A n. Very good. All right. So, well, these are grade 10 exponents. All right, equals. So what are we going to do? We're going to do this fraction, 6.67 times what? 5.98 times what? 7.35. All divided by what? 3.92 to what power? Square. No, this is just this part. Just this part. Times. Okay. This one. 10 to the negative 11 times 10 to the what? 24 times 10 to the what? 22 divided by 10 to the, is it 16 or 10? No. When you have exponents, you add. See? See? No. Okay. Some people are saying 10, some people are saying 64, and some people are saying 16. How can you get 10 from 8 and 2? Are you adding here? Is this the rule for addition? Yeah, no. What's the rule for addition? Everyone. The rule for addition is what? The rule for addition is you have to have how many bases multiplied by each other? 2. A times n, A times m. What do you do here? What do you do here? This is where one you add. Okay. How about if it's A to the m to the n? So it's 16. It's 16, not 10. Again, I am guilting you into thinking it's 10. It's not 10. It's what? Why did you say 64? Ali said 60. He said, oh, A to the m to the n is equal to what? A to the m to the n here. No, you don't square a power. You just what? Multiply the two powers. You see what I mean? When you have a shell inside of a shell, you just multiply the what? The powers of the shell. Make sense? And, and, and why do you think people love being in my class? Because I assume, you know what? I told you first day. What did I tell you? I assume about all of you. I assume all of you, and I don't care if you took advanced calculus. I assume all of you can add and subtract numbers, and I assume that none of you remembers the multiplication table. Don't take it. Don't be offended. Don't be offended. Do not be offended. No. I am holding you to a very low what? Low bar, because then I'm gonna lift all of you up. Okay. So what's the rule here? 10 to the what? 16. Okay. Come on, people. Can we do this? Oh, my bad. Can we do this? Sorry, 16. Can we do this in our head? Yeah, we can. What's 24 plus 22? 24 plus 22. 46. 46 minus 11. Take away 11. 35. 35 on top. Take away 16 because you're subtracting. Remember, when you divide numbers, when you divide powers with the same base, you just subtract the exponents. What's 35 minus 16? Come on. 19. Okay. Juman. You're just what? Because I'm doing here? Fine. Trust me. This is not called genius. This is called experience. Okay? I did not invent any new math. I just know a lot of math because I've been alive for 41 years. That's all. Okay. What's my power? Everyone, listen. What's my power? How many people here got a power of 20? 20, not 26, 20. 20 is the correct one. And how close is 20 to 19? Very close. So at least I know that my answer has what kind of power? 19. Do you see how so far? By the way, so far did I ask you to do any calculation for me? So far, I'm a self-containing system. I am doing my own work. Now, look what I'm gonna do with this. Hold on. Pencils down. Everyone, pencils down. Everyone, guys. Do you think I can do this in my head? Not the way it looks like, but I'm a king of approximation. What's a number very close to 6.67? 7. Thank you. What's a number close to 5.98? What's 7 times 6? 42. What's a number close to this? 7. So it's 42 times 7, right? Forget the 42. Let's make it 40. You see? I'm scheming the system, but to a point. What's 40 times 7? 280. Thank you. Dude, 4 times 7 is 28. Add a 0. 280. If you're saying what the hell to this, you have got to really listen up, everyone. How many people are applying to university? Any program? Do not believe your hype. Do not believe your hype. You have a lot to get ready for. You need to get ready. Ask them. They're writing the physics midterm tomorrow. The engineers and the science people. They are getting terrified. One year, some emailed me about the 5 kinematic equations, telling me they're teaching us 5 different ones. They're not. Instead of delta D, they call it delta X. They got so terrified, they thought there were 5 new ones. They couldn't even see that the mathematical structure was the same, like VI delta T plus half A delta T squared. They got so terrified that the notation was slightly off that they thought that now we have 10 equations, 5 from Mr. Ramadan and 5 from first year. You need to be ready a lot of math and physics is not just about solving the problem. It's about what? Understanding the philosophy of it. Do you see what I mean? So if you're saying 40 times 7 is equal to 280, is how the hell did you do that? Please know that you have a lot of practice to do before you spend that 8 grand in science or 16 grand in first year physics. Please. So now, Hamad, what was this one? 280. What's this number close to? 4. What? 16. So I have 280 divided by what? I don't want to do 280 divided by 16. I want to do 300 divided by 15, right? It's closer. What's 300 divided by 15? 20. So the answer is what? Hold on. Hold on. That's what they teach. That's why they teach you. That's what they teach you in university. To do things quickly, even if you're off, but you know how much you're off by. So this is equal to what? Is this in scientific notation? No, it's not. 20 is not in scientific notation. 20 has a decimal point right here. I'd like to put this in scientific notation. What would this be? So what would this be? 2.0 times what? Times 10 to the? Guess what the correct answer is? 1.9 times 10 to the 20. Look how close I am. Do you see? But no. Did you just see? Did you just see the David Copperfield magic show I just pulled? How did I do that? 26 years of helping people. I am not smart. I've just been in the ring. Thank you. But do you see at least how big I know my answer should be? Is it exact? No, it's not. But is it close enough? Sorry. Do you see my point here? This is my point. I use this as my supercomputer. You screwed up using actual supercomputers because you had no idea how to plug it in. That means what? I am smarter than you plus your own machine because I built my own machine. Practice, practice, practice. What again? You know what's no. You know what's the sad thing? Everyone says what? Practice makes perfect. Everyone does it on the field. No one does it in learning. Everyone practices for sports. This is a sport. This is a muscle. What's 9 times 8? You see how many people got stuck, got stumped? You can't do that. You have to be ready. Okay. All right. So let's do this one now. Come on. Let's do this one. Okay, everyone. I'm going to do this one. Exact. I'm just going to plug it in. All right. So 6.67 times. No. And now I'm going to show you how to get the actual answer. All I did was the what? Approximation. Times 7. Everyone. 7.35. Divide. Oh, I don't like this. Now it's good. Divided by. What do I do with this? I put it in what? Brackets. Thank you. So bracket divided by bracket. 3.92 squared. I think it's here. Close the bracket. 19. Because it's 19 times 20. Everyone, it's 19 times 20. So sorry, I mean it's 19 times what? 19 to the power of 19, which is what in scientific notation? 1.9 times 10 to the 2. Yes, thank you. It is the same thing. We're doing forces. All forces are measured in what? Newtons. N. Okay, I have a question for you. How big is this number? Yeah, I'm not good with very big. Give me a physical sense. I need a physical sense. I'm going to show you something now to really make you understand how big any number could be in like real life sense. Question for you. Everyone, what's my power here? Okay. I know I did not teach you scales. I will do at some point. What's 10 to the 3? 10 to the 3. 10 times 10 times 10. Come on. 1,000. Do you know what's the name we call 1,000 in Latin? Huh? Maybe I heard it. What do you call 1,000 in Greek? Kilo. Kilo. Okay, what's 10 to the 6? A million, right? What's a million? Huh? Yeah, but what is it? Kilo. What comes after kilo? This is important to know. No, mill is small. We're doing big. Mega. No, no, not omega. Omega is a character in Greek. Mega. M-E-G-A. What? What's 10 to the 9? A billion. Kilo. Mega. Starts with G. Giga. Tera. And so on and so forth. 20. Is 20 a multiple of 3? No, it's not. By the way, the scales are only done in threes, right? 10 to the 3, 10 to the 6, 10 to the 9. I want to play with the exponents. I want to play with the exponents. What does that mean? Give me 3 numbers, everyone. Give me 3 numbers. Listen up. Give me 3 numbers that add up to 20. 2 of which should be the same and multiples of 3. Give me 3 numbers that add up to 20. 2 of which should be the same, and both of these same numbers should be multiples of 3. Come on. No, 5, but neither 5 or 10 are multiples of 3. I need one of them to be a multiple of 3. 3, 3, 3, 3, and 14. Okay, I agree. Make those threes bigger. 9, 6. Okay, if you do 6, it's gotta be what? 8, 6, and 6. Let's do what? 2 and 9 and 9. Hold on, everyone. Do you agree that this is the same? Do you agree this is the same? Raise your hand if you agree this is the same as 10 to the 20. Good. Hold on. Let's look at the 10 to the 9. What did I say 10 to the 9 was? No, a billion. What's a billion in scales? No, sorry. Kilo, mega, giga. So a giga is a what? What's this one also? What's 10 to the 2? Just 10 to the 2. No, just 10 to the 2. 10 times 10. What's 1.9 times 100? You see how we play with the scale? I am showing you how to take a big value of an exponent and actually understand how big it is in what? In common number sense. How much force is pulling the Earth and the Moon together? 190 billion. Billion what? Then here's my question to all of you. Then how come the Earth and the Moon did not crash into each other already? This is not an easy force. This is an insane level of force. A gravitational too. How come nothing happened so far? Not that I want anything to happen. How come nothing happened yet? I don't want anything to happen yet. Sure. Physics 11 scientific reason. Their masses? Sure. Okay. Look. Yasmin is trying to just grasp. She's saying normal and black hole. No. Nope. But far away, I agree. 190 billion? That will pull you in no matter how far you are. You see, we only talked about how many gravitational forces. Is there only one? Question for you, everyone. Let me show you. Okay, Baha, you mentioned that you want to do astrophysics or something? You want to do space science? All right, let me show you how insanely complicated astrophysics is. Question for you. Everyone, check this out. Let's okay, what's this? What did I sketch? Two what? Two spheres, two balls, two spheres. How many interactions between them? Just what? One. Okay. One interaction. Let's add another particle to the mix. So now I have how many particles? Does the existence of a third one negate the existence of the first one? No. So, but how many interactions do we have now? So let's make a chart. Number of what? Particles, number of forces. So for 2, it was just one, right? How about this one? 3, it was what? 1, 2, and okay. Let's add another one. Are the original 3 still there? Yeah, they are. Yeah, they are. That'll be 6. 5. I already have 6 non-negotiably taken. They're there. But now I have what? 6, 7, 8, 9, Even though this one is between, there's still what? It still feels it. Do you see what I mean? The existence of something in between two does not mean that the gravitational force is canceled. It's still there. So it's what? 10, right? What's happening? Is it what? It's increasing. And is it increasing at a linear rate or a non-linear rate? Oh, you can sketch this. It will never follow a line. You know what it would follow? Did anyone here take data management or is thinking of taking data management? We're going to take data management. There's something called factorial, which is basically what? The question, the exclamation mark. The more you add, the more what? Interactions you do. Can you imagine if you have 8 planets? How many forces of interactions do you have? A few or a lot? No, much more than that. My point is, do we just have 8 planets in the solar system? We have an insane number of things, right? What do we have? We have planets. What do we also have? We have star. Well, we have only one star, technically, in our solar system. I'm talking about the galaxy. What else do we have? We have moons. We have dwarf planets. What else do we have? We have meteors. We have asteroids. We have the entire asteroid belt, right? Yeah, I'm keeping it simple. Just our solar teeny tiny system. Can you imagine how many interactions are there? Okay, here's my question. Everyone, your hand. Pull him. How many forces do we have now? 2. Pull him. Pull him too. Do you see? Okay, relax. It's not a tug of war. What's my point here? When you pull in different directions, is force a scalar or a vector? When there's a bunch of vectors randomly oriented, do you think they're more likely to add up or cancel out? That's why the moon and the earth has not what? Smashed. Because the moon and the earth are not just pulled by themselves, they're also pulled by what? Every single other thing, no matter how close or how what. But the further it is, the what? The weaker the effect. Is it making sense now? So don't just be fooled by the big number. There's a lot of other big numbers in there, and they're all acting what? Are they all acting as scalars or vectors? No, forces. Which means what? Sometimes they add up, sometimes they what? They cancel out. And that keeps the whole thing in what? In motion. Is it making sense now? There you go. Let's do it. What do I write first? What's the equation? 6 point. Okay, everyone, watch this. Look, 7. Do I use times 10 or exp? Because otherwise, I'm going to have to use so many brackets. exp, 11 with a minus. Times what? 5.98 exp 24 times what was it? Mass 7.35 exponent 22 equals all of this is the top. All of this is the top of G m1 m2. Now I'm going to divide it by what? What do you divide by? Distance squared. So I'm going to have to use a bracket. Divided by, open a bracket. What's my distance? We agreed to it's going to be what? 3.92 times 10 to the 8. Okay, square it, close the bracket. You ready? Ta-da. Your homework. What's your homework? Yes. Aha. What did I tell you to do? Google what? Let's Google it together so at least you have the numbers so no one uses different numbers. Okay. All right. Let's what's the first thing we have to Google? What did I say? Mass of sun. Okay, everyone. Mass of the sun. 1.99. Just use 1.99. Go ahead. Just write that number somewhere in the problem. Mass of sun, or ms, small m, capital S, or whatever, is 1.99 times 10 to the what? 30. So the sun is about 10 to the 30 divided by 10 to the 24 is about what? Is about 100,000 times more massive, heavier than the Earth. Okay, what's the other thing I want? Come on. The distance from the what? From the surface of the Earth to the surface of the sun. All right. So sun, Earth, distance. There we go. Surface to surface, 148.96 million kilometers. What's an easy number? What's a good approximation to this? Thank you. Everyone, make it 150 million kilometers. Go ahead. 150 and then comma 000, comma 000. So 6 zeros after the 150. 150 million kilometers. What's the last thing? I know the radius of the Earth. I know I need center. So radius of the sun. Well, we're talking about the sun. 6 that. Come on. I'd rather you do 696 with 3 zeros. Everyone, listen up. We're gonna make it 696,000. We're gonna shave off 340 kilometers out of almost 700,000 kilometers, which is not even 1%, not even 1,000. I know. Done. That's it. That's your homework. Yeah. So we're gonna make it 696,000. We're just gonna take out the 340. That's it. Done. Whew. That was a lot. 696,000. And what was the rate? What was the distance? What did we say, Tammy? 150 million, not 148, just 150, 3 zeros, 3 zeros.